Hi, everyone. My name is Ben. I'm an Android engineer at Airbnb, and I work on the native infrastructure team. And today I'm going to be sharing our story of how Airbnb scaled from an application with just a couple of developers and a single module into one with over 200 modules and roughly on the order of a magnitude of 100 developers contributing to it this year. So let's start off with a tale of two apps. It's back in June of 2011, and there were two Android apps being built. The first, you might recognize. It looked a little bit different back then. But it was this app where you could rent out a room in your home to a stranger. It was being built in San Francisco in an apartment on Rouse Street. And it was created by three co-founders who came up with this idea when there was a design conference and people needed a place to stay. Now, all the way across the country in North Carolina, another app was being developed. And let's get the real effect going here. It had great visuals, great sound effects, and it was being developed by this really cool guy, this high school senior. But the crazy thing is, when these apps were being built, they started off exactly the same way. We just, started a new project in Android Studio, applied the application plugin, but the big difference was the Airbnb app has continued to grow and grow even more. Whereas Spelunky's Last Stand, the name of my game, well, it was only ever downloaded by my friends and my parents. Airbnb's organization, likewise, grew a lot, and eventually they made the strange choice of hiring the developer of Spelunky's Last Stand and gave me this cool drawing. There's as you grow, there's like this phenomenon called Dunbar's number, which is this fancy term that says that the amount of stable relationships that one person can comprehend is capped at 150. And what organizations do to deal with this is they start to structure themselves. So Airbnb broke itself into smaller business units. And you can do the exact same thing with your application. So you can take code from your application module and modularize it by moving it into a library module. And under the hood, what's going to happen when you build your application is your library module is going to have its own manifest file, your own resources, your own classes. Your application module will still have all of those, but then the build tools is going to merge it into a single APK or Android bundle. And this talk, I have to make a lot of these diagrams, so I just want to clarify something. When you see something like this, we're going to read this as application depends on library. And again, these library modules are primitives for modularization in Android. And the art is you can really do whatever you want with them, almost. So you can have one module depend on many modules. You can have a very deep structure. The one thing you can't do is have a circular dependency. And we're going to see how we deal with that later. But the first rule of modularization is you don't modularize if you don't have to. So it's something to keep in mind if you're working on a smaller app. A lot of the things I'm going to talk about, don't even worry about it until it becomes a problem. But that begs the question, how do you know when it becomes a problem? So throughout this talk, we're going to visit this project structure report card, and I've identified a few areas that I believe modularization can help. The first are build times. So as soon as you add your second module to your project, you can turn on this flag in Gradle. And this pretty much says, let me use all the cores on my computer to build my modules in parallel. So to see the impact that this can have in your project, I created a little dummy project where I just created hundreds of source files and ran builds overnight and see how long it took. So you can see that as you add source files, your build times are going to scale relatively linearly. Now, when you add your second module, it cuts pretty drastically. Diminishing returns from more modules, but definitively modularizing your code can help build times. The next big area that modularization helps with is code ownership. And there's sort of two aspects to this. The first is attribution. So we've all been there. Some piece of code is not working. Maybe you got to assign some crash. What do you do? And by default, if you're using Git, we all have this one tool, which is git blame. And this is really easy to use. You just right-click in your gutter and see who wrote the code. But the problem here is it's not durable. We've all heard the adage, what are you going to do when your teammate gets hit by a bus? Or maybe less morbidly, what are you going to do when they go to the company down the street? Git blame's not going to work, and then you have no idea who to ask. So we can move out a layer of abstraction and try to use something else as our unit of attribution. So you might consider using file or classes. And this has the potential to be really cool. You can add annotations directly to your code and maybe build tooling around this. But think about how much effort it would take to annotate every single class or every single file in your code. And furthermore, like in the event of a reorganization, you would have to go and update all of these. So at Airbnb, we actually found that modules make a really good unit of code attribution. All you need is one manifest in it declaring what team owns the code. This is really easy to do. And in a reorg, you just have to update a handful of modules. We've probably all heard of Murphy's Law, which is that whatever can go wrong will go wrong. I want to propose an amendment to this, which is Murphy's Law of code access. And that's that whatever they can access, they will access, and it will go wrong. So to illustrate this example, let's say our application is a monolith and it's a mall. I'm opening up a coffee shop. Life is good. I'm using a coffee grinder. What could go wrong? Well, this guy named Murphy decides to open a coffee shop. And I think we know what Murphy's going to do. He's an entrepreneur, he wants to cut corners. So he uses my coffee grinder, sort of sneaks into my shop every time someone orders some coffee, grinds it up and returns. He's doing great. But, I don't love this. I want to be differentiated. So I decide I want to become a boba shop, and I use a boba machine. And what happens is Murphy now becomes a boba shop. So that's not great. And this is where modularization can help. We can actually strictly enforce that someone does not use your code without their permission. Furthermore, if you're using Kotlin, there's literally a language visibility modifier that operates on this basis, and that's the internal modifier. So likewise, we don't want Murphy to use my boba machine. We probably don't want the mall to know about it either. So we can mark that internal, and that won't be visible. And the final reason that I think you should consider modularization is if you want to leverage some of the new features with app bundles. So in the world of applications, bigger is definitely not better. Google did a study a few years ago that saw that for every 6 megabytes that your app increases, your install conversion drops by 1%. So that means that, what is the percent that when someone clicks to download your app, that they will successfully download it and launch it? It doesn't actually scale completely linearly. If you were to go from a 100 megabyte app down to 10 megabytes, you would actually see your download conversion increase by 30%. And the math doesn't actually add up there, but it's interesting. When I first saw this a few years ago, I thought this was really silly. If I have a 100 megabyte app, I'm not going to be able to make it to be 10 megabytes. But my view on this changed this year when Google announced app bundles. And the idea there is Google will actually repackage your app, and they can highly optimize it. In terms of this talk, the most important and most relevant part is a concept called dynamic features. And dynamic features pretty much says, I want to take a few modules in my app. I don't want to bundle them with the initial install, and I want to make them dynamically available. So for the rest of this talk, I want to talk about how we modularize at Airbnb. So again, we have over 160 modules, I think closer to 200 now. And we also have this concept of light builds, which I'm going to really dig into later in this talk. But this allows you to build a small sliver of the application in much less time. And you might be like, 2 to 5 minutes, well, that's pretty bad. My application builds faster than that. For context, the entire Airbnb application on a local dev machine on a fresh build could take up to 20 minutes. So this is pretty substantial. And jumped over that. We learned a lot of lessons. So let's see what those are. There's no way that I'm going to fully be able to explain how all 160 modules in our app works. So let's simplify it down to just 2 things. On the right, we have Airbnb Experiences. This is a product that we launched about 2 years ago where you can learn how to make pasta. And then on the left is a traditional homes product. So fairly similar pages, but owned by completely different teams. So again, let's take a step back and to see how our organization is structured. I actually learned from a talk earlier today that there's even a law named after this. It's called Conway's Law, and it's natural. You're going to want to structure your code the way that your organization is structured. So what that means in terms of project modularization is we want it to modularize by feature. Before we get into that, though, it's intuitive that there's going to be some foundation that everything is going to be built on. We call this our base module. Other people call it core. And there's a few rules here. This is going to be pure infrastructure. And what this means is there's absolutely no knowledge about Airbnb. And our litmus test to see if that's working is we can ask ourselves, could this be open sourceable? This, again, one of the theories throughout this talk is that every module is going to be owned by one team, as that's our unit of ownership. So this is owned by the native infrastructure team. And one rule that you'll see throughout this talk is it's incredibly important to keep your base module lean. So we do not allow any deprecated code in base. So the next layer above base is going to be your features. These are, again, owned by a single team. And they encapsulate a single feature. And I know that sort of sounds like a tautology, so to give it a little bit more flavor there, we sort of explain that by whether or not there's a single entry point. So if I'm creating a flow with many pages, I might not be able to go into page 3. So each page of that flow doesn't need to be its own feature module, but the larger flow should be. But generally speaking, with modularization, smaller is better. And what this implies is that a team may own many feature modules. And one tricky thing and one very important rule is feature modules cannot depend on other feature modules. And we'll see more on this later. And the last layer is some sort of application shell. This really should not do anything that interesting. So no feature code, no infrastructure code. The one thing it does do is create our Dagger component. And it's a pretty important job. So let's just see if this structure theoretically could achieve the goals that we want with modularization. So we have a lot more features, and we make some change to the experience module. You can see that this is only going to have to recompile a very small amount of code in the app. So we can have pretty fast builds with this. In terms of code ownership, using modules as the primitive for ownership, we can mark all these to a team. Some teams own more than one. None of the teams can touch other teams' code. And in a reorg, we can just pretty easily remap them. And for app bundles, we can take some of the features. Let's say maybe we want to take all the hosting features in the Airbnb app and make them dynamically downloadable. And we can just move them out like that. So overall, this looks pretty good. But even using this structure as your starting point, you're going to immediately run into some challenges. The first one that I think everyone will need to deal with is how you do navigation. So let's start off with a pretty simple example. On a listing description page, if you scroll all the way to the bottom, you're going to see a section called Similar Listings. And this just allows you to see homes that are like the one that you're staying at during the same date range. So this is code in the same module, so launching the screen is pretty easy. You can just create an intent for an activity, and you can launch it. Now imagine that instead of showing similar listings, we wanted to show nearby experiences. And what is really tempting, if your code is structured like this and you can't access that activity directly, is for the homes module to just depend on the experience module. We can find that class and it all works. The problem is the experience team might decide that they want to show nearby listings. And when they try to add that dependency on the homes module, you'll get a circular dependency and your build will fail. And it only seems fair that it shouldn't be whichever team adds the dependency first that gets to use it. The experience team would not be happy if they can't do this because the homes team beat them to the punch. So what we've created is actually something incredibly simple. It's just an intents module. It's like a universal navigation directory. And it depends on absolutely nothing. So this means the only thing that you can give it are primitives like IDs. And it returns intents and fragments. So the fact that it depends on nothing might be raising some red flags in your mind. And you'll see why when we were using reflection. So that's sort of crazy, right? Like Airbnb is using reflection for navigation. What are they doing? It actually turns out to work really well. So using that primitive where you can load a class, you can start writing code like this that returns an intent or a fragment. And I think the power of this model is the fact that the code that you get back is nullable. And it's becoming increasingly clear that there are cases, valid cases, where something that you're navigating to is going to be null, especially if you're going to try to start leveraging dynamic features. There's a very good chance that what you're navigating to doesn't exist in your APK, and you need to go to the Play core library to download it. Another possibility, and we'll dig into this more later, is that you're on some sort of debug build that's not building all the code in your application. So the page that you might be trying to launch doesn't exist in the flavor that you have. So we want to show like a little toast to the developer saying, hey, download this flavor if you want to go there. And the last reason is a developer deleted the activity or fragment in the intents module, but forgot to delete the references in the code. This is bad. This would be like a mistake in our architecture if we allowed this to be a common occurrence. Luckily, this is pretty easy to remedy. You can just write a unit test in some sort of module that knows about every other module. And if you attended our talk on CI, you know that at Airbnb, we do not allow you to merge a PR until all the code has passed its tests. So it's actually impossible to delete an intent without deleting it from all the places it's being used. So we've never had this problem shipped to production. Now, based on this model so far, it seems pretty restrictive. Like, we have a lot of feature modules. They're all very small. They don't depend on each other. We have this base module with only infrastructure. You know, as a developer, there are valid cases that you want to share code, and sharing code is a good thing. And there are cases where there's just no way around it. So consider a wish list feature. And a wish list, we want to be able to wish list both homes listings and experiences. So what this means is we probably want some sort of wish list manager. And if we were to put it in the wish list module, this isn't accessible by the other modules, per our rule that feature modules cannot depend on each other. So what's very tempting is to move it to a place that it would be accessible by everyone, and that's base. And this was actually a mistake that we made at Airbnb. We allowed this to happen for over a year, and what ended up happening is our base module grew. And we started having all these weird things that were business-specific code in base, and this sort of breaks all the reasons that you want to modularize your code. You have this one root module that's really big, that's going to take a long time to build, and you have no encapsulation. So we introduced the concept of a library module. These are similar to feature modules in the sense that they're owned by a single team. But the big difference is they have no launchable features. So you can't just create a library module that launches a feature and call it that just because it's a workaround to share code. And what we found is that this actually forces better code, because when you design a library module, you're sort of thinking in the sense of, this is an API that I'm sharing with the rest of my team. So instead of going into some other team's code and writing some switch statements to add my product logic, I create that as a library module, which is consumed and clearly depended on by other code. And I just want to reiterate again how important it is to keep your base module lean. So from an architecture standpoint, it would look pretty weird, but your application should be not quite a triangle, more like a diamond, like a very thick feature layer and a thin app layer and a thin base. Lib modules help keep that pattern true. But even your own infrastructure is going to run into the case where it starts to grow over time. So we used Guava at Airbnb for a while, and it was nice. But then we discovered Kotlin. And Kotlin, in pretty much every way that I can think of, is just better than Guava. So we want new features being built to use Kotlin and not Guava. But remember our rule. If you can access code, people will access it. If you can use Guava, even if you have the option to use Kotlin, people are going to accidentally use Guava. So we can use library modules to solve this problem too. We can create a lib-deprecated Guava, have all the existing modules in the app depend on that, but all new modules only depend on base, which has just Kotlin. So it's a good way to communicate best practices in your organization. And the final challenge I want to share today is how to upstream dependencies. So to illustrate what I mean, we have a concept at Airbnb called a trebuchet. This is just a feature flag. And the idea with a feature flag is you're asking your server whether or not your feature is on or off. And We could do this every single time we access one of these feature flags, but that means it would be pretty slow. We don't want to go to the server just to decide whether or not we want to show screen A or screen B. Ideally, we would create one request in our base infrastructure and make it when we start up the app. But the individual trebuchet keys themselves, we want them to be declared with the code that owns them. So we want the homes listing trebuchet keys to be declared in the homes module. We want the experience keys to be in the experience module. So now we have this tricky problem where this trebuchet request that we want to have all the trebuchet keys in the app should be owned by our base infrastructure, but we don't know what the keys are in base. And we can't just add a dependency on all the feature modules because we'll get a circular dependency. Now, we could put this in our shell module, but we created some rules that there should be no infrastructure in the shell, and the shell module should have a single owner. This is just one example of why you might need to use a pattern like this, but there's many, and some of which are feature specific. So if you were to extrapolate, allowing this in the shell module would lead to a module that's very big and owned by many teams. So we can use a pattern called a plugin architecture. Our base module can declare some sort of interface. Think about it as a socket. And this socket is going to be this trebuchet key. And the base module will also say, I know of some interface, or I expect to be given some object that is going to contain a set of trebuchet keys. I don't know what those trebuchet keys are, but I know that I will get some set of them. The plugs are the trebuchet keys themselves, which are declared in every module. And then all the way at the top, you can think about it as some sort of operator that tries to find all the modules in your app and construct the actual instance of your set. So looking at that a bit more closely, inside your application on create, you'll want to create an instance of this base graph declared in base. You'll want to add all the trebuchet keys from all the modules. And then you'll want to pass that interface, the implementation of that interface back to base. And there is some code that you have to write here. Specifically in this set, you have to list all the trebuchet keys that you depend on. The good news is this is not really logic. This is just manual work of identifying what modules in your app and creating a set. And we use Dagger to manage our dependencies at Airbnb. And Dagger specifically has a tool to allow you to do this with no work. So, talking about Dagger in a multi-modular project could warrant its own talk. So I'm going to keep this at a pretty high level. But our rough structure at Airbnb is our app shell contains our Airbnb component. This is our root Dagger component. In terms of scoping, this is like our application scope or our singleton scope. And every single feature module will have its own subcomponent. And we allow feature modules to scope that subcomponent to whatever lifecycle makes sense. And in Dagger, you sort of have this concept of a module. And a module is like a glorified factory. And it makes sense that for the homes listing trebuchet, we would want it to be declared in some module inside the homes listing module. The big problem with this is when we launch the app, we don't want to create all the subcomponents in our application. So the homes listing subcomponent might not be created, which means its trebuchet won't be accessible without creating the component, and we can't provide our base module with everything to load. So we introduced the concept of app modules. These are little plugins separate from your main component that are installed on our main application at launch, and this is where you can participate in multi-binding, which is the term Dagger uses for this pattern. And what this means is when we launch our application, our subcomponents can remain unloaded, but we have access to all our trebuchet keys. So we actually found this to be a very important pattern, and we named the project where we migrated all of our modules to follow this pattern, the Unified Dagger System. And specifically what that code looks like, roughly, and the purpose of this code, again, was for multi-binding, is some base module declares that it expects some set of items, trebuchet keys in this case, and that is achieved just through adding a multi-binds annotation. Inside a feature module, every single feature module has a Dagger file that looks like this. Now, you have the subcomponent that you can do whatever you want with, install it, whatever modules you want. You own this. But you also have this app module and this app graph. And these are going to be installed on our root Dagger component. And again, this is where you would actually provide the instance of your trebuchet keys. And then the only code that goes in our app shell is this little configuration where we list all the app modules that we're going to use. We're going to list all the graphs, and the graphs are going to allow you to expose the builder that then creates the subcomponents. And that's all you have to do. Now, what this does mean is we are building one giant component with little pieces from every module, but we don't expose that to a given module because a given module only knows what graph it uses, and our base infrastructure will just return a little slice of that. So we still have all the goodness that comes from proper code encapsulation. So we've come a long way so far. We started from this single monolithic application. We've broken it down into feature layers, libraries, our core infrastructure, and our navigation library. But even with a structure like this, it's not going to maintain itself. And people, it's complicated. Like, it's already taken me 26 minutes to get this far. People are, they're just not going to remember how to do it. So you have to build tooling that's going to maintain your structure. So a given module actually has a lot of boilerplate. That has this trebuchet key file that I just talked about, this Dagger file that I explained, and of course, their own build file and resources. And as Android developers, we get really excited when we see patterns like this with duplication, and they're like, I'm going to go write an IntelliJ plugin, and this is going to be great. I'm going to give everyone this plugin, and they're going to click create Airbnb module, and life is good. I actually propose doing something much simpler, and that's just using a scripting language. So in Ruby, if we wanted to create this trebuchet key file, it's really just a string replacement. We just need to give this file a name. This is all the Ruby code that you need. I think we all can understand this with just a couple minutes. And we can ship this very easily to all our developers. You can just give them a script. They have one folder in their project where they know to look for all their scripts. And so distribution is pretty easy too. I want to conclude today taking a look at Airbnb Lite. And this is this concept that I've been hinting about, allowing a developer to build small slices of an application. So if we were to continue looking at our clean build times as we scale the number of modules, there comes a point where additional modularization doesn't really help your build time anymore. So this grand project that I've been talking about sort of fails at one of its core missions. But what is interesting is if you were to somehow reduce the number of files you were building from in half, your build time would actually also drop in half. And we can leverage the structure we built so far to do that. And under the hood, what we're actually leveraging are Gradle or Android flavors. So if you were to go to the Android documentation website and try to research what a flavor is, you're going to see this example of creating a demo and a full app. And the reason I think they cite is that if you target API 21, your builds will be much faster. But maybe you want to ship to more APIs. So you can just create a demo flavor, and this will open up a Gradle command that builds it with that configuration. But flavors are much more powerful. You can actually have flavors depend on different code. So if we go back to our app structure, if we just introduce one more layer, a flavor layer, we can configure which modules we include in the app. So a homes flavor would only include the homes module, whereas an experience flavor, the experience module. And to keep things consistent, our full flavor includes all the modules in our app. And going back to build times, something I want to remind you is another way to label this x-axis, instead of hundreds of source files, you could just call this time. Your application is going to grow over time. And the big difference with light flavors is the amount of code that you're building in a light flavor does not grow over time. I mean, a little bit, but relatively speaking, it's going to be consistently fast. So right now, some of our light builds are up to 80% faster than our full build, and that percentage is only going to increase. So for light flavors to be successful at Airbnb, we wanted a few things. It needs to be easy to create a light flavor. Everyone here maybe has a few flavors in their applications that you spend a lot of time creating. But we have these very small feature modules, and we want it to be just a matter of minutes that you can select which ones you want and have a new flavor. And this is actually easier than you think to achieve. You just have a developer say what flavor module they depend on in some sort of configuration file. And then it just takes a couple of Gradle for loops. So this one, we're going to iterate across all the flavors that we've declared, create a new flavor. Depending on if the developer said they want this to be installed as a separate application, we might add some sort of flavor suffix to the application ID. And then the last step is one last for loop where we actually install the flavor module. So in the case of flavor homes, we'll see that this adds the flavor code, which then looks at that module's build file and then adds all the modules it needs. And again, the only responsibility of your app shell is to create that Dagger component. And it turns out that all the information you need to generate that Dagger component is contained in this dependency block. So a developer doesn't need to even do anything to set up Dagger. So flavors introduce this possibility that some of the code that you need in your application might be missing. And if this was a nuisance all the time, developers would hate using flavors and they would start building the full app. So our structure actually allows this to work pretty well. In terms of Dagger, if I'm missing modules that have trebuchet keys, those just are not going to be included in the multi-bound set. And that's okay, because we're never going to use the code that looked at them anyways, so that set just changes. In terms of navigation, if I'm in the experiences module and I would try to launch a homes listing, we have this nullable intent system, and we just pop up a toast to our developer that this module is not installed. But what's really exciting is that flavors can be more than just faster. You can make developing on a flavor a better experience. So the first example here is creating a custom launcher. So inside your flavor module, you can write code that's only available for you as a developer. And in this case, this is what happens when you launch our homes listing module. And this has a bunch of interesting things. It's super easy. You can jump into a page for a listing without having to navigate through the normal flow in the app, or even jump into a page that shows a translated listing. So you can take all the things that you want to test when you build a feature and build out a launcher to handle all of those. And the last little tip I want to leave you with is module unloading. So when you start building tons and tons of modules and have tons of code, IntelliJ is going to slow down. It's just going to be indexing everything. You're just going to be frustrated because you're not even able to open up Chrome while it's doing this. So what you can do is use this structure that we've built to unload all the code that you don't need from your flavor. So what I just did right there is I told IntelliJ to unload all the modules in my application. I'm then searching for the experiences flavor that I want to load. And sort of through the same dependency process that we just looked at, IntelliJ will just load the modules that it actually needs. So you can see when this finishes, the vast majority of the modules on the left-hand side of this page are going to go red, and that means that they were unloaded. So this literally, when you use this for the first time, it feels like you got a new computer. So I just want to give a shout out to Gabriel Peel, who did a lot of the initial work on setting up Airbnb Lite. And he's here today at this conference and this talk. Just closing, it's a really interesting time at Airbnb. We're going through this modularization process. You may have heard from Gabe's talk earlier that we have this framework called Mavericks that we're using for all our features. Epoxy, which has existed for a couple years, but it's been pairing really well with Mavericks. We're just starting to look at GraphQL and server-driven UI. So I'll tell you, I have time for a few questions, but I'll be hanging around, and if you want to ask me about any of these things, feel free. Thank you. Sure. So the question is, I introduced this concept of string-based navigation, And why would we not just use app links or deep linking or something that we already probably have existing in the code base? And that's a great question. So we do have a deep link dispatch from Airbnb, which is a library specifically for deep linking. So we leverage deep linking heavily. But if you go back and look, we're offering behavior that's more than just that. We allow you to both load activities and fragments. And Airbnb is actually a primarily fragment-based application. Furthermore, I only showed you like a little snippet of what we're allowing you to do, but there are things that we want to enable that is more powerful from just deep linking, such as, given a fragment, we may want to be able to tell the navigation system to give that fragment a heads up that we might want to be loading it soon, and it can preload itself. So it's just mostly for flexibility, but you're right, they are pretty similar, and one of our goals is like a page that we can access with our routing system should be pretty easily accessible from deep links as well. Yep, that's a really great question. So for the sake of simplicity, I completely left out our UI system in this structure. So we have a whole set of modules specifically for, and sorry, I think I forgot to repeat the question. The question was, where do we keep resources in the base module or somewhere else? So again, we have a completely separate structure that looks very much like what you saw today. So we have team component libraries using our design language system. And those libraries have cases where they need to share code, so they have library modules. And you can sort of imagine, if you were to imagine what this looks like from a schematic perspective, we sort of have a duality for both library modules that we saw today and these component libraries. Yeah, the question was, can I give some examples of what type of infrastructure code is in our base modules? I mean, the one that you saw today, trebuchet requests, is one. But besides that, when we were incubating Mavericks, like that type of code would belong in our base module. And everything from like experimentation to like base logging frameworks. And we also have some base classes for our activities and fragments that we put into our base module. Yes, so the question is my answer, which is and now I'm trying to remember what we said. I wish I could just give you the microphone, but yeah, when feature modules become too big, we break them apart. And then anytime that we need to share code that was previously being shared, we use this plugin pattern that we went over today. So when we do that, we do not have to move code into base necessarily. We create library modules. And I guess one thing I didn't go into is we do allow library modules to depend on other library modules to solve that case that you're describing. Oh, Gradle, yes. So the question is Gradle becoming too slow? What part of Gradle specifically are you? Yeah, so I mean, as I mentioned, like it takes 20 minutes to build our app with Gradle, our full app. So that's why we introduced these light flavors, which build very fast. Cool. I can just take additional questions up here at the stage, but thank you for coming by today.